In this video, we're going to solve a practice question on multiple regression, question number 10 from chapter 7, and we're going to use data file BeachFrontHotels. So here I have the question. So all right, yeah. So this is a multiple regression question. We want to, there is a survey-based data set, and we have the scores on comfort, amenities, and in-house dining, and also an overall score for the satisfaction of the customers. And here in this question, we want to develop a multiple linear regression equation that can be used to predict the overall score given the other three scores: comfort, amenities, and in-house dining. So that's just part A. Conduct a multiple regression and write down the equation. Part B, test to see if each one of the independent variables are significant or not, and alpha is given to be 1%. So we want to we want to test the significance of variables at 1% level of significance. And part C, it says remove the independent variables that are not significant at 1% level of significance, and then run another regression model, find another estimated regression model, linear regression model, and then make a comparison between the model from part C and part A. All right, so let's get to it. So this is the data file. I have overall scores. This is my dependent variable, the variable that I want to predict, and these three are my independent variables. They're the candidate independent variables that I have. So I'm going to run first a regression model that includes all of the three. So I'm going to go to Data tab, Data Analysis, Regression Tool, and here I have some inputs from the a previous question. I'm going to remove those. All right, so Y range is going to be the overall score, and it's going to be column B, overall scores, B1 to B21. X range is going to be comfort, amenities, and in-house dining all the way to the last row, C1 to E21. I do have labels, and I'm going to put the output in, let's say, H2. And I also need the residual plots for making the statistical inference. Okay. All right. So this would be the answer to part A of the question. And then the equation would be, I'm just going to write down the equation. Equation is going to be overall score is going to be the intercept plus the coefficient for comfort times comfort plus the coefficient for amenities plus the coefficient for in-house dining times in-house dining. 0.247 times dining. All right, so that's the equation that explains overall score based on the other three factors that customers have responded. All right, so comfort, amenities, and in-house dining. All right, so that just answers part A of the question. Part B, use the t-test to determine the significance of each independent variable. What is the conclusion for each test at 1% level of significance? Usually, when we want to do the statistical inference with respect to the individual parameters, we need to check the necessary conditions for residuals. And also we need to check, since we're dealing with a multiple regression, we need to check for multicollinearity. I'm gonna do those first, and then we're gonna read the p-values. So going back here for part B, I'm gonna check the necessary conditions by looking at the residuals. When you look at the residuals, we need to check, we need to make sure that the residuals are symmetrical around the mean of 0, and the variance is constant as we go from, so we should have like approximately equal number of points above and below 0, and the variance should be constant as we go from left to right. So, I mean, this one looks good. It's just, you see here, we have approximately equal number of points above and approximately the same number below the point. So that's this one is fine. This one is also, I mean, here it looks, all the points are positive at this side, and then here you have approximately equal above and below. This, honestly, this one also looks okay. I understand that here you have most of the points above the line, above 0, which is not okay. But given the small sample size, that happens really, that sometimes you may have, at some neighborhood, you may have all the points. It's just 4 or 5. It's you may actually see those type of things when you are dealing with small samples, and that's still okay. For this one, however, if you look, I mean, still it's a small sample, and it can happen really, even if everything is perfect. But if you look at the chart, there is some sense of non-linearity. So you see here, so we have most points negative, and then most points at the middle of the range positive, and then here also we have some significantly negative points here at the lower side of the range. So negative, positive, negative. So mean of error is not constantly equal to 0, as opposed to this one, where the average is, relatively speaking, equal to 0 always. Whereas for this one, no, it's not the case. We have negative, positive, and negative again. So that can be a red flag. That can be something that we may need to double check. So I'm gonna check the necessary conditions for residuals. Necessary conditions, residual plots look okay. The only observation, the only probably violation of necessary conditions might be amenities. The mean of error for amenities is not always 0. is not always 0. So we have negative at the lower side, positive, and negative. So this looks like a quadratic type of curve, all right? So the mean of error for amenities is not always 0, negative, positive, negative. All right, so that's for necessary conditions. Next thing that we need to check would be multicollinearity. And we check this only when we're dealing with multiple regression, all right? So I'm just gonna move these guys to the bottom of this data file. So for multicollinearity check, I'm just gonna check to see if it exists for now. I need to get the correlation between independent variables. Each pair of independent variables, we need to get the correlation. I have 3 independent variables. Therefore, if I pick subsets of 2 out of 3, a total of 3, I will have 3 correlations to calculate. Comfort and amenities, comfort and dining, dining and amenities. So 3 possibilities. I can write down the correlation function 3 times, or I can use the correlation tool. So for correlation tool, you need to go to data, data analysis, and correlation. So here you just need to pick the 3 variables, select them, C1 to E21. They're grouped by columns. It means that each column represents a separate variable. Labels in the first row, that's perfect. And then just put it, I'm just gonna put it right below multicollinearity check here, and 3. So I have now, I mean, these ones, that's okay. It's comfort with comfort. It has 100% correlation. That's understandable. But comfort and amenities, comfort and in-house dining, amenities and in-house dining, like I said, 3 correlations. All of them are below the absolute value of all of them, below 0.7. So multicollinearity does not exist. So multicollinearity does not exist. Basically, this is not a problem anymore, because it does not exist because all correlations are small, and by small I mean below 0.7. All right. Okay, so multicollinearity does not exist. Necessary conditions are more or less satisfied. I can go ahead and perform the statistical inference. For statistical inference with respect to individual parameters, I just need to look at the p-values. And if I do that, a level of significance is 1%. So the only one that is not significant is this one, comfort. As you can see, that one among the 3, the p-value for amenities and in-house dining is less than 1%. This is less than 1%. This is 0. This is also less than 1%. This one is not less than 1%. So this is the only one that is insignificant, all right? That is not significant. So I just mark it with the red color, and I just put a note here. Comfort is not significant at 1% level of significance. Why? Because its p-value is greater than 1%. So if p-value is greater than alpha, that's a bad thing. That's a sign for the variable not being significant. All right, so this is not significant. So now for part C of the question, remove all independent variables that are not significant at 1% level of significance. And what is your recommended estimated regression equation? Now we have model 1. Now we're going to perform another model. We're going to develop another model without comfort. All right. And we're going to compare these two models. So we have part 1, part A. And now I'm going to put part C maybe. So we don't need comfort. So I just make sure that I just make it, just change the font color to red, just so I know that this should not be included in my new model. So now amenities and in-house dining. I'm just gonna put part C right below the data set here. So it's gonna be data tab, data analysis, regression. Column B is fine for Y range overall. For X range, I just need to pick column D and E. So D1 to E21, this range. Amenities and in-house dining labels, and I just put it right below here. So it's gonna be A24, and I still keep the residual plots. I think it's gonna have a problem with this one, but let's see. Yes, let's cancel that. And I just need to put it in another place. So I'm gonna put it right after my part B. I'm just gonna put it in Z1. All right, so this should be okay now. Or maybe Z2. And this is gonna be part C of question. Get rid of this one. So now we have part A, part B, and part C. For part C, let me just write down do basically the same thing that we did in part B. First off, writing down the equation. So I have overall score equals intercept plus the coefficient for y-intercept plus the coefficient for amenities time amenities. So it's going to be 0.25 253 plus the coefficient for in-house dining 0.8 dining. All right, so now I have a second model. All right, and if I check the p-values for this one, I mean, before you check for p-values, again, if you want to check for necessary conditions, the residual plots look exactly, I mean, very, very similar to what we had. So nothing really changed in terms of the residual plots. Multicollinearity correlations are going to be, we already saw that it's multicollinearity does not exist. So, and between amenities and in-house dining, we have a correlation of minus 10% or 11%. So that's, again, is not a problem. I can go ahead and say both variables are significant at 1% level of significance. Now, which model would you recommend out of model in part B, the model in part B, the model in part A, and the model in part C? So I have, when we want to compare two models, we need to check the adjusted R squared, and we also need to check the significance, the simplicity of the model, which is by the number of significant variables. All right, so adjusted R squared in my first model is 70%, 70.3, 70.8. All right, so model one, adjusted R squared. Model A, model C, 70.3, 70.8, 70.8%. And I'm talking in percentage. So I just, all right. The significant variable in model A, we just saw that 2 out of 3 are significant, and in model 2, 2 out of 2 variables are significant. So obviously, the model that is simpler, I mean, all the variables here are significant, and it has slightly larger R squared, adjusted R squared. So definitely model C is more preferred. I just called it model C, but I mean the model that we developed in part C of this question is more, that model is more preferred.